Hello, everyone. I'm Eli Plaskett, Senior Associate Editor with Modern Machine Shop. Welcome to today's presentation, Digital Augmentation, the missing element to your frontline operations. The presentation will be led by Tulip Community Lead, Russ Waddell, and Senior Product Marketing Specialist, Jacob Dupuis, who will introduce us to the topic of digital manufacturing. Russ Waddell joined Tulip as the community lead in 2022 after working for the Association for Manufacturing Technology since 2007. He most recently managed the MT Connect Institute, a standard development organization for machine-to-machine communication. He previously was an industrial economist at AMT and holds a bachelor's degree in economics from the College of William and Mary. Jacob Dupuis joined the Tulip team in 2020 and has had a huge hand in telling the stories of the Tulip products. Working in product marketing, he combines a technical and creative background with previous experience working in marketing for education, additive manufacturing, and edge computing. He holds a bachelor's degree in management engineering and operations from Worcester Polytechnic Institute, where he completed long-term projects in London, UK, and Reykjavik, Iceland.
Thanks so much, Eli. I appreciate it. Jacob, how are you doing this morning?
I'm doing good, Russ. How are you doing?
I'm good. Are you ready for this?
Yeah, let's kick it off.
That's the only right answer because we're doing it whether you're ready or not. The agenda today, we're going to talk about where we stand in digital transformation. So we're going to look a little bit at how we got to where machining and discrete manufacturing are today, what things look like on sort of the digital landscape, a little bit of history and a little bit of sort of high level concepts around maybe some of the pain and some of the places where there's room for improvement. And then we're going to put forward a theory from Tulip and from Jacob and I that there's a missing piece here and that there's a gap that needs to be filled, and it's mostly human, not mostly software and not mostly equipment. From there, not to give you just a conceptual pitch here, we're going to get into some specific details on how to get started, talk about sort of a framework to deploy in your own thinking and in your actual shops, and then get into some specific examples of how this has worked in the past and some cases where folks have had success with this with the Tulip platform. Jacob, take us to a poll while I get this set up. We're going to ask the audience a question here.
Yeah, so our first question here is kind of a loaded one. But in your opinion, what are your biggest pain points in your daily operations? So the poll should pop up on the right-hand side. We have a few options here, ranging from best practices for running a machine shop, technical maintenance of your equipment, recommendations for software, knowledge transfer to new operators, and data collection. And so this is going to help us steer the conversation. Just feel free to take a minute to answer that, and then we'll revisit the results from this poll later.
Thank you, Jacob. I clicked the buttons and the poll has appeared in the poll tab for the audience. We'll come back to the answers to that when we get them coming in. So I'm going to do the introduction piece and kind of talk about the high level stuff, and then I'll turn it over to Jacob to get into a little bit more detail. The real gap that we see in digital projects has to do with a mismatch between hype and reality. So the reality day to day that machinists and managers and shop floor people and the production workers and the people that are in their kind of chain of command, there's a huge disconnect between what they're looking at as an immediate problem and what software vendors and to some degree equipment suppliers are offering as well. And there's two real reasons that we got to this situation. So the problem comes when you have a somewhat niche industry in machining where you have two sources for new innovative software. One, you have companies that are coming primarily from a manufacturing background and they're pivoting away from operations excellence and technical skill at machining or production type operations. And they're moving from there into software. So this is companies with sort of an industrial heritage, you could say. And this is a place where there are pitfalls from very, very large companies down to very, very small companies. So on the biggest side, you have, large Fortune 500 manufacturers who will spin up a software division, hire a bunch of software people, and then try and push that software. Where that tends to start to fall down is the same place as it does for the small companies, where a very small shop will spin up a piece of software based on maybe what they've been using to run their tool management, or what they've been using to run their scheduling, or something like that. Both of those places have a challenge because you don't have software companies that have a long history of software sales, support, go-to-market strategy, maintenance. Just the way they interact with customers doesn't necessarily jive with what you would expect from, say, consumer software. You think about buying Microsoft Office, not necessarily a wonderful experience for every person who uses Microsoft Office. I don't mean to sugarcoat that, but at the same time, you have a stable and expected experience that you and a healthcare worker and somebody who works in education and your family members and your kids, they all have the same basic software procurement, onboarding, understanding, and support experience, because that's general purpose software. Now, when you get into manufacturing specific software, the general purpose software doesn't necessarily fit that mold, but the specialist software that's coming in doesn't necessarily have the benefit of the established vendors. So you have gaps on both sides, right? The software vendors who are experts at software don't have the amount of manufacturing experience that you'd like to see, and the manufacturers that are coming into software don't necessarily have the software experience or systems in place to support that you'd like to see. Now, I don't think anyone has done anything wrong in either of these situations. I think that the issue here is primarily just a matter of maturity. So when we talk about digital maturity as an industry, understanding that this is where we are, and that frustration with any type of software vendor that you're interacting with is basically part of the history of manufacturing, machining, and kind of the discrete industry overall. This is basically a step along a journey. And if we fast forward 20 years, most of the stuff will be resolved and things will be much easier. Nobody cares about what's happening 20 years from now when it comes to the problems today. So I don't want to dwell on what it's going to look like in 20 years. I mostly want to point out that the way things are now means that a shift in attitudes and a shift in approaches is important to overcome the gaps that just occurred because of where we stand kind of in history. Of course, I would be remiss not to talk about the over-roboticization of industry, the promises of a robot on every line, and automation to the point where we remove people from the operation entirely. This is a nice future. This is a conceptual future. This exists in academia. I don't know that it exists in reality, right? The arguments here are as old as computers on the factory floor, and that can be frustrating that we're having the same debate 35 years on about what's the right fit for automation versus what's the wrong fit for automation. And the problem comes from one-sizing everything and assuming that, small part runs and large part runs with differing amounts of part variability all have a one-size-fits-all solution. Everyone who's in manufacturing knows that there is not a one-size-fits-all solution, and that everything will be, to some degree, custom tailored at some level. So when we talk like a robot is the answer to every problem, that leaves out a lot of legacy things that are actually worth respecting and understanding the value that's been built up over time. Now, the most blatant case of this is saying let's get rid of paper in all our operations because paper is immediately out of date, and paper is there's no way to feed back into a computerized system, and that's all well and good. But I think that the counterintuitive point that I want to bring up here is that a paper system might exist because there's a very good reason to use paper. And taking a process-centric approach and taking a person-centric approach will get you to a different conclusion than necessarily you need to remove paper. So understanding that a paper process has matured over time to a place that's stable, it's consistent, it's reliable, and it's repeatable, that adds business value by being all of those, having all those traits to it. And deciding to rip that out and replace it because now's the time that we're going to do a digital transformation project, it's missing the core pieces of what makes that process successful as it stands. Now, including what a person is doing in a process. This is assembly shown here, but the same thing holds true for machining processes. Understanding how a person and the computers around them and the paper pieces and whatever they're interfacing with, understanding that process more holistically gets you to a better outcome. And it really comes from manufacturing fundamentals. So understanding how to see what a process looks like, how to see what's going on the floor, and how to then incrementally improve that process. So it's taking a continuous improvement attitude as opposed to I would say a procurement based attitude to how you're going to go about transformation. Now, this is not to say that every process is supposed to be paper, or that there's not lots of outdated, old, crusty processes that need to be, revamped. It's mostly when you're talking about the actual procurement and understanding what software can do. Think about what that person can do that's incremental improvements, particularly in terms of where there's software or hardware interface to that software. So that's thinking about what the digital and the physical look like when they converge a little bit more, as opposed to one just replacing the other. Part of why we got here, and I don't want to necessarily create a culture war, but this will be a familiar concept, that you have essentially suits coming up with a digital transformation idea. This is an executive who went to a presentation and heard about Industry 4.0 or Industry 5.0 or whatever the technology of the day is, and has basically decided this is the time that we're going to do this. Well, that's not taking a journey approach to it, and that's not taking a continuous improvement approach. That's taking I want to go get a big win and do the thing that's splashy and flashy. And the problem is that doesn't necessarily apply when you actually get down to the shop floor and you're trying to see who needs something today that they can solve. So if you're walking around with a clipboard today and we're going to replace that with a tablet, maybe that's the right approach, but maybe that tablet is not actually as good a substitute for the clipboard as you think. Or maybe the value of the tablet is not so much that you're walking around with a tablet, so much as it is that you're cleaning up the data that was behind whatever went into the clipboard. There's plenty of cases where digitization is basically transporting what was a paper-based process to a digital process, but it's really not just taking that and turning into digital paper, right? So the idea of a PDF that you can fill out instead of a piece of paper, that leaves behind all sorts of integration and extra benefits that you get from a truly transformative approach, and that's the type of thing that takes a long time to actually deploy. I think this probably shouldn't come as a surprise for most of this audience. The result here is that we kind of have a missing the mark situation where there's some stagnation and some frustration, particularly on the case of people that are trying to buy software. The number of companies that say they haven't reached their goals, as reported by McKinsey here, we're seeing that this is the vast majority of companies falling short of what they're trying to accomplish with digital transformation. And the adjectives that we hear about, and that I think are familiar to everybody here, are that these types of projects tend to be expensive, they're siloed and full of political battles, they're non-sustainable, they're excessively complex, and they're not simple incremental fixes, because that's not the way that enterprise software is typically sold, and it's not a way that the small company software is matured enough to actually be offering. So I don't want to spend too much time complaining or bemoaning the current state of affairs, so much as I want to just point out that there's still work to be done and there's still room to grow here. And that's not just true of you or your company. You're not the only ones experiencing this sort of, let's call it software misery. There are lots of other people that are in the same boat as you. The point to make here is that there's a big gap between what actually is being done, say for visibility into a process that's mostly manual. It's going to stay mostly manual. We're not going to put a robot in here. There's room to make that more of a highly visible process using digital tools. But that making the process visible and then layering improvements on top of that newfound visibility, there's no way to spec out a software implementation project for a manufacturing environment when we're using old-fashioned ways of setting up a project. So the idea that we're going to buy software like we buy capital equipment, big unwieldy RFPs for big unwieldy software, months-long projects, that only works when you're talking about things that you would consider large scale, high impact initiatives. And there's room to have those sort of high level initiatives that are still adding a lot of value to the company. But where there's a gap is tying that into what's this actually mean for buying software that's going to help us today, help us tomorrow, and help us, in a transformational way a year down the road. And the biggest gap that, from Tulip's perspective and from Jacob and my perspective, the biggest gap here is that there's this detachment between layers, right? So we've stopped asking the engineers and the operators who live in these processes what their ideas are. And the only thing worse than forgetting to ask is ignoring the ideas when they do come up. And that's something that I don't think is a software specific problem. That is, a good manufacturing operation has systems in place for doing that. The thing that changes with a digitally transformed organization is that the ways that communication communication goes back and forth, have layers of software and layers of hardware connectivity to a process stuck on top of what's already good manufacturing processes and good continuous improvement initiatives. The shift here is and this is in buying and deploying and maintaining digital systems and software. The shift needs to change from being exclusively process centric, where we're thinking primarily about the machines themselves, our CNC equipment, materials and supply chains, and then our enterprise wide software. And if you're a smaller company, don't think that this doesn't apply to you because I'm talking about ERP or MES software. This is whatever the software systems you use to run your operation. Those three pieces are all very technically focused, and having the idea that your workforce, your personnel, the people who interact with these systems are, they're neither commanding the systems nor subservient to the systems. They need to be sort of central to that system itself. And the old ways of applying technology to manufacturing have created this sort of a digital divide. So it's not like the idea of let's put software into the factory is remotely new. This is, again, a decades old movement, and it's sort of a decades old incremental movement. But there are too many places where manufacturing, particularly discrete manufacturing, is still looking at software projects with this long memory of how the last project was installed 6 years ago or 10 years ago. And those sort of cycles are not really applicable in today's software world. And the place that we're going, and again, it's not like anyone is doing anything wrong here. It's just the tide is shifting, and the ability to put a person at the center of these systems and to take the decision making and to take the insights from the people at each point where they have the best information or the best knowledge about what needs to change, and put that in a very integrated way into the middle of these technologies and systems. That's where you can cross this digital divide and get your company to an actual transformational space. And that's true for all manufacturers, and that's true for those that are doing it, best in class. But even the ones that are best in class, this is a continuum. So I don't want to make it seem like this can all be fixed with buy Tulip and this will solve all of your problems. There's a journey that still has to take place, and there's steps on that journey, and moving away from this divide between the machines and the person and closer towards the person and tight integration to the systems. That's something that anybody can do at any time across all of manufacturing. And the steps to get there can be simpler than it looks like, even though over the long term, this is a very big and significant project to try and take on. So the way we describe this at Tulip is we talk about digital augmentation and human centricity. We also talk a little bit about democratization of coding and some other concepts. But the core piece here is that we want to get away from this idea that we're going to automate people out of manufacturing processes. And in fact, we're going to treat people as the resource that they actually are in a manufacturing or in a process intensive case, where the digital solutions come in and they take things that people are good at and they make people better at the things that they're already doing, or they allow people to do things that they weren't able to do before. And that decision-making piece, particularly where you can push the decision-making to whoever knows the most, is critical to this continuous improvement mentality. And I think that the funny thing about this idea of augmentation and the idea of maybe shying a little bit away from full-blown automation is that this is very old-time manufacturing principles. This is not a new or revolutionary concept. This is that continuous improvement attitude and approach. And this is the things that have made for world-class manufacturing since the Industrial Revolution. So it's surprising how much the ability to return to fundamentals actually improves the ability to get better outcomes in a digital space when you have equipment that's run by computers and it's increasingly networked, and you have people who have increasing computer literacy, bringing them the tools that they need in bite-sized pieces that don't ignore a larger systematic improvement on the whole. That's what this augmentation approach is about, not so much bringing in robots and replacing all the people. So just another example to drive it home. Think about our paper-based process, right? There's all these steps that have to take place. And these are pieces of information that have to be carried in an assembler's brain or in an operator's brain, and there are pieces of information that are coming from a wide variety of sources. It's coming from places outside of a workstation or outside of a machining cell. There's information that's coming from computers and devices that are at that cell. So this is coming off the CNC itself, or coming from a tool management system, or coming from sensors that are applied, or tool break detector or something like that. So all these additional sensors, systems, and basically computers all around where there's a manufacturing or an assembly process, these things have to converge, and they converge very frequently into a person. And as they converge in that person, the thing the person is doing is basically managing this orchestrated system of information in, information out, and activities in and activities out, right? And we're all still talking about, raw material, or a partial assembly comes in and finished product, or further assembly comes out the other end. That concept hasn't changed at all when we layer digital on top of these things. But as we look around sort of a paper-based cell, there's no such thing as something that's fully paper-based. What was the source of the paper? Where was the CAD file? Where was there's digital always involved in any current manufacturing operation, except for the absolute most artisan cases. So you end up with something where augmentation just means making more of each of the pieces of digital technology that are around those stations. So you have cameras installed at a station that can observe a part. Now, those cameras are useful because they can do two things at once, right? They can observe a process, but they can also feed information back. So if I'm an assembler standing at a Tulip station, I can take a video of what I did and how that differs or varies from the work instructions that were supplied to me through the Tulip platform. And I can say, I followed the work instructions. This was a slight variation that I took on these work instructions, and that can be fed back very, very quickly as an improvement. So it's two-sided. We've spent a lot of time in kind of the old paradigm looking at how the information is shoved to the operator, to the person, and then the interface back to systems is fill out this form, or stamp this, or pass this piece of paper. All of that stuff can be more flexible and handled better on the fly when we think about that from a digital mindset. And that doesn't necessarily mean that everything has to be overhauled. You can start with what amounts to the same process, but you work on, where do I integrate a data collection piece at the cell? Where do I work on a data integration piece from the CNC to the backend systems? As I work on that integration, what's the end goal for what this actually is supposed to look like? So the ability to integrate little pieces of technology quickly and rapidly iterate on those is something that's been missing from basically the entire manufacturing industry until very recently. And where Tulip fits into this is to basically bring in the ability to have another layer of middleware where we do connectivity down to these digital data sources. We do connectivity to the person with digital work instructions or feedback from the operator into a digital system of record. And then finally, the ability to deploy that in a software-centric way that's going to be rapid iteration and quick feedback from, here's the thing that actually is happening, or that's going well or going wrong. How do we change that? How do we tweak the process? How do we improve the process? And not have to go back to a software vendor who put in a monolithic system to manage our entire process as a one-off that then requires, massive change orders and big amounts of investment to try and, overhaul everything to fit how we're going to do it, tomorrow or next week. So with the human-centric approach, there's primary pains that you're going to be able to address. And these are kind of the greatest hits of what the pain points that we think you're going to be able to solve with this human-centric approach. You're going to have better guidance for the workforce. That means that they're going to have what they need at their fingertips and at their eyes when they need it. That usually means a screen or a tablet, but it could also be a printout, as long as that printout is still tied back to the digital system and there's some way to feed back any information that's stuck onto the printout back into that system. This leads to things like improved utilization and improved quality. The last mile problems of connectivity come up when you're thinking about, well, how do I tie in this or that piece of digital data source that wasn't necessarily designed to be a digital data source for the rest of a system? It was designed to do, whatever the unitasking function that it was designed for. But what would it look like if we tied that to a better system where that system can consume data easily from a wide variety of actual devices, or feedback from an operator where they're actually talking about events that have taken place? The next level is that you kind of get to your real-time visibility, and then you move from the visibility to insights. And the insights piece of this is maybe a little bit further down the line. The insights is taking all this information that used to be disparate or largely paper-based. We've made it digital. We've made it accessible. We've made it useful to a new class of people that can now dig into and analyze that information. And don't necessarily think of this as analyzing it in a series of silos. A machine tool builder or a control manufacturer has layered all sorts of extra analytics and insights into controllers as we get from generation to generation to generation of new software for machining. But think about not just how that exists on the CNC, think about how that exists in the hands of anybody who needs it anywhere. And there are real problems still to be solved about how to actually get there. But when you're thinking about this in terms of that, put the person in the center, put the process in the center, and think about this as a long-term journey, it will help you guide your decisions about what you're actually looking at next in terms of software procurement, the costs and the effort of maintenance, and basically what life with software looks like as you move forward on a digital transformation journey. All right, Jacob, you're up again. Take us to the poll while I figure out how to send this to the audience.
Yeah, so the next poll should be live. So our question here is, which of these things that Russ just talked about are the most pressing for you? Just going through the list: guiding the workforce, getting real-time visibility, improving utilization, improving quality, fixing last mile problems, and getting proactive with insights. So it looks like we have a bunch of results pouring in for this. And we're going to dive into each one of these and kind of give examples in our proposal of a journey to go through this digital augmentation process.
All right. Thank you, Jacob. And this is probably a good time to go back to our to the last poll as well and bring up what we saw as the results from the last poll. So the first question was, in your opinion, what are the biggest pain points in your daily operations? And we had the majority of answers there were knowledge transfer to new operators, and the second most popular response was data collection, meaning was that paper-based data collection or just a non-consistent data collection. There was no one answered that their biggest pain point was technical maintenance, and nobody answered that their biggest problem was recommendations of software. So as you're answering the second question, we'll revisit this in a moment. Keep in mind that knowledge transfer and data collection were the primary pain points for the vast majority of our audience today. So, Jacob, talk about the composable approach to Agile implementation, and talk about this gap between how software has been deployed versus how software has typically been deployed in manufacturing.
Yeah, so this proposal that we kind of put forth to our customers and to people that we talk with and work with is an agile method of kind of approaching digital transformation. And so it's not just taking a big multi-year long RFP, working over it over a long time, and then kind of just deploying it suddenly. We are proposing starting with single solutions, adopt them gradually, build a single use case, find like a checklist app or a work instruction, and something that starts giving you that visibility and that insight, and collect feedback from it. So get the operators involved, see what they think, see how they could improve this, see how the process is working for them. And then you can iterate on that and work in like cyclical sprint method, and adding more features and adding and addressing their feedback each time. With a platform like Tulip, where you can create your own solutions, this is pretty easy. We're laying the foundation of digital transformation there throughout the whole thing. And as you build another solution, 6 months out, 12 months out, 18 months out, you have all of that value from day one. And you're just seeing a snowball effect of more and more value, and not just deploying it 18 months out and then starting to see value over time there. So this is kind of a gradual method that is easier to implement and easier to tackle, and it breaks it up into smaller projects that you'll see immediate return on. So how can you get started with this? So as Russ mentioned, all of these different categories that we see being important steps, you can kind of take a look and see where you fall in this journey. This is like not a prescriptive journey. This is just a proposal and something we often see. Usually we have people start coming to us asking about real-time visibility, or if they're asking for how to improve their quality, we'll see if they have that visibility in place. If they can't identify a cycle time or their scrap rates, then this is a good place to start. So you can make that foundation for improving your quality down the line. As we go through this, we'll have a few examples coming up of customers that we've seen be successful at every stage of this journey. So keep this in mind, and we'll send these slides out so you can kind of place yourself and think about where you are in this journey. And we'll have the results from the poll shortly to kind of see what people are thinking about.
Yeah, I can take us to the poll now. So the question in the poll, let's revisit that. Which is the most pressing issue? And it was a pretty much a tie across 5 of these issues. So workforce guidance, the first option, real-time visibility, improving utilization, and then finally proactive with insights. Those were all basically within 1 or 2 responses of each other. These are within 3%. So the only things that were tied for second place were improving quality and fixing last mile problems. I think the thing that ties that together is the visibility piece as a precursor to analysis and action. And I think that rings true for most people that are working in a machining environment. And that's relatively consistent across discrete manufacturing as well. And I think that's one of the things that tends to trip people up is what sells is not necessarily these intermediate steps. What sells is here's the big fix that's going to deploy our digital journey. And so from a vendor's perspective, it's very easy and very tempting to come in and say, we're going to solve some large holistic problem for you, when in reality, that large holistic problem has to be solved with a series of incremental fixes. And those all have to be tested and rolled out in a way that's actually going to make sense. And that kind of gets us to the framework that we talked about here, where seeing a real fix as early as possible, and then deploying additional fixes on top of, basically infrastructure that's laid out underneath that digital infrastructure. That's an approach that's not necessarily widely adopted in manufacturing yet. And it's how you get to resolutions to the biggest and most pressing issues that we've seen in the poll results. Jacob, I'm not going to steal your thunder. Let's take it straight to the customer examples next.
Yeah, so the easy way to talk about kind of what results people can see is to share what results our customers have seen through processes like these. So first up, we have an example of a large industrial manufacturer who was lacking visibility into production and scheduling, and process owners were working on paper and spreadsheets. And at the end of the week, they'd check back and see, and often there was mix-ups, there were missing data points, and this was occurring every single week, week in, week out. So what they were able to come up with working with the operators is building a terminal that connects to their scheduling service and their ERPs, and pulled that data in automatically for operators to see what they have to do for the day and update the status in real time, which gave process owners and their team visibility into where every single order was in the entire facility, all at once on a single dashboard. So they could easily drill down and see exactly where an order was, exactly who was working on an order, and get rid of that paper traveler that was going with the order, which eliminated mix-ups and made them no longer have to sit and sort through that data at the end of the week. So they could focus more on deploying other improvements with all the time gained back from, in this case, the continuous improvement engineer. And so this is a pretty good place to start, and a good example of just a single app. It's super simple and table-based, but deployed across every single operator's workstation. This transformed the way they work and kind of reduced those errors and simplified order processing.
And Jacob, the continuous improvement engineer who was responsible for these processes and responsible as essentially the product owner for the software deployment, this person would have a walk around essentially every single morning, talk to the operators, get feedback on how the app was working. Simple things like what is the layout, where are the buttons, what additional buttons are needed. Those were discussed every day, and she was able to go back to her office and make those changes on the fly. So it was a 24-hour cycle basically. We noticed that we've rolled out the software, we want this thing changed or this thing added, and she was able to do this on her own. There was no back and forth with the vendor. She was able to roll this stuff out, and that was sort of unheard of. And when I talked to her about this in depth, this was just her expectation, was that was something she'd be able to do. She hadn't worked with another piece of software before, and she came into this explicitly expecting to have that kind of a quick turnaround time. And that change in expectations is what's going to happen over time in discrete manufacturing. That's going to get us from where we stand today to what that, kind of living up to the hype future looks like. So I just thought that was a particularly specific example of most of the value of this installation came from the ability to capture information really, really, really rapidly and go from, people-centric information to captured in the product in the tool itself extraordinarily quickly in a way that most manufacturers aren't really thinking about at this point.
And that's a really good point. That speaks to our next example pretty well, Russ, with all of these people coming into the workforce are kind of expecting that flexibility in software and expecting to be able to kind of like make those improvements or use something like Google Docs and some technologies that they're familiar with. So with this next example for guiding a workforce, we have a robotics solutions manufacturer that was building out a new line. And so they had a lot of new incoming workforce that had never really assembled things like this before or worked on any of the processes that they were doing. So their process owner developed work instructions on the go for people's mobile phones and tablets, which are interfaces that these workers were familiar with. Everyone has a cell phone nowadays. Everyone at least is familiar with the intuitive navigation and kind of expect that while they're working. So being able to have these on-the-go mobile devices with visual work instructions and with error-proof steps so they could take pictures or scan barcodes, this was really beneficial for them as they were deploying and training all of these new operators across the line. And these work orders can be built these work instructions can be built as simple as like a machine changeover checklist, or they can be as complicated as assembling a robot in this example. But the key is that agile implementation where you can start small and deploy a simple text instruction with a picture, and then you can implement a barcode scanner or add kind of capturing a defect reporting chart and capturing a photo of a malfunctioning part or warped part. So as you kind of are deploying this and expanding, people will become more familiar. And to Russ's point, people will have feedback on how things can be improved, and improving them and answering that feedback is really the key also, and making sure operators really want to be using this software and this solution.
I love this example because it flips the script on sort of this old, machine shop meme of the shift supervisor coming around and telling the, young guy to get off his phone. And in this case, you're doing your job on the phone, right? So it's kind of ironic to me to see this shift over the last 5 or 10 years from, phone as a major distraction and a waste of time to turning into an actual resource when it was, it was sitting there the whole time as a potential resource. And there just wasn't the maturity in the platforms and the tools to actually work on mobile to have that stuff get to the point where it was going to be a tool instead of a distraction.
Exactly.
What's our next one?
Our next one, so improving utilization. This was a big one in the poll. This goes hand in hand with getting real-time visibility. Machine shops have machines, and everyone wants to know how those machines are doing. In this example, it's a little machine shop adjacent. We have batch manufacturing with a baked goods line. So they're making breads and they're making baked goods, but they have machines and they want visibility into that. So working with a tool like Tulip, they were able to capture machine data coming off those machines and put it into something visual and easy so they can drill down to exactly how machines are working and kind of see the status of their entire line in a single place. And the value here was that operators could add context and notes through digital apps as well. So I might be able to see that I have a machine down on a certain line, but being able to know that from the operator that it's down because they're on a break or it's down because of a broken tool, that context is very valuable and kind of adds to understanding how our machines are being utilized. And so we have another example for improving utilization as well. This customer of ours was a job shop with hundreds of CNCs. and injection molding machines and all kinds of equipment, but they lacked visibility into this. These machines are running day and night, and scrap builds up. And having a lot of scrap production or not really understanding what's happening was starting to become costly. So their solution from the process owners is to create these apps that connect to networked machines or connect to stranded non-networked machines with sensors and edge devices so they can start collecting data from everything and centralizing it into that one place, into those dashboards, really getting to understand how much scrap is actually occurring and being able to address that. And more importantly, saving operators time. If an operator can see at a glance how the machine's going, they know they have some more time to work on something else and get the next job lined up, which is giving them, in the end, the chance to deliver to their customers more effectively.
And as we go through these examples, think back to, some of these things are kind of mature, right? So the idea of machine monitoring is either all the way mature or rapidly maturing around kind of the machine shop space. But think not so much just about that as a fix, but think about, we saw scheduling, we saw machine monitoring, we saw process visibility and improvement, we saw on the fly updates. Think about what your machine monitoring software can do next and what else it can do, and think about where it's being installed, what it's being installed adjacent to. So how well does that fit with everything else? How well does it take the operator input versus digital input versus equipment input? All of those things tying together is kind of where we see expectations. It's appropriate to raise your expectations at this point from what your, what used to be one purpose software is able to actually do.
And so once you kind of have that visibility in place as a baseline, you can start to tackle some of these last mile problems where your production for the most part is running smoothly, but now other little things are popping up, and you'll see that it's just solving these little issues around your shop can have huge impact on return and like reducing operating times. So in this case, this sinter metals manufacturer, their production was pretty good. They had visibility into what was happening, but they kept running into this issue of tooling and molding being not where an operator needs it, no real way to track it, and didn't really tie this to their production process. They didn't think about it, but being able to address it and build an app that could catalog and log all of their tooling and molding, tracking it and centralizing all of that data alongside work orders was huge for them. So they were able to reduce operating times and improve traceability. They could integrate scanning and checking in tooling in their workflow that the operator is already doing. So as they're starting a machine changeover, they can scan their tooling, and then it's logged in the system where that tool last was. And it helped with maintenance, being able to track how often a tool is being used, how often a mold is being used, kind of helping aid that and avoid that extra downtime or those extra delays and steps outside of their regular process or what they thought was their regular process. This last example is a luxury goods manufacturer. They're making jewelry, and they have little visibility. So they had work instructions in place, but quality with expensive stock like this is huge. It's very important. So their solution was to build a log application, kind of tracking where orders are, tracking quality defects. It could integrate very well into the workflow that the operators were already going through, where they can quickly report a defect, and then that's logged and stored, and error proofing what was happening with the operators. So ensuring that they're scanning barcodes at every step, they're making sure serial numbers are aligned. All in the background, the app is doing all of this work for the operator. They're just going through their workflow, maybe picking up a barcode scanner, hitting next, and they have all of that contextual data right there. And the process owners have all of that data also, which is leading to zero errors from barcode scanning. They had improved throughput from operators and were able to make more in the same factory. And they had a reduction in quality defects because people were kind of passively aware of what was going on. They knew that they couldn't go to the next step without scanning, which made them double check their work. And they're able to log and track those root causes of quality. And so we don't have an example for the proactive insights today. I know a lot of people were interested in that, so please reach out. We recommend often that people tackle these first few steps before moving on to kind of this advanced data collection and contextualization and machine learning. But if that's something you're interested in, we're happy to talk through that with you. So yeah, be sure to reach out on our website and we can definitely get you the information we have on that.
Jacob, tell us the stuff that we should keep in mind here.
Yeah, so some key takeaways. This process, or if you adopt a similar process like this of being agile in your digital transformation and augmentation, it's a journey. So remember, you're not going to necessarily be fully transformed and have all of these return immediately, but it will happen very quickly as you start to deploy some of these changes. And to keep these changes sticky and to make sure people want to use them, get feedback, like collect feedback from operators, make sure they care about and feel like they have a voice in the solutions that are deploying. And these solutions will last and they will stay. And bringing a no-code platform like Tulip and like building your solution in this is flexible. And saying flexible is something that everyone here has probably learned over the past few years. It's important. As Russ said earlier in one of the examples, being able to change something on the fly or adjust an app based on feedback is huge, and it's an advantage for you. And lastly, keep humans at the center. Change comes from these operators, and it's most effective if we're augmenting and not automating away their jobs. They'll be thankful by the amount of new and easy to use intuitive features that you're bringing to them, and you'll be thankful by the returns. So yeah, Russ, do you want to wrap it up with some critical themes from this whole presentation?
I'm ready to put a bow on it.
Awesome.
So Jacob did a good job of summarizing this in terms of the framework in the last slide and sort of what things you ought to be having front of mind. But the overall theme here and what we want you to take away is that the focus overall here is shifting. The idea of retaining workers and keeping new talent coming in the door is going to come from things like shifting attitudes to how you deploy digital technology. And that's partly because the expectations of that workforce are changing over time. The exposure to good software is ubiquitous. It's everywhere. Every single person that you're looking at to hire will have had exposure to high quality software that integrates tightly into another environment. Now, unfortunately, that's not necessarily going to be something they've seen in manufacturing. And the ability to deliver that sort of thing in a manufacturing space is going to be a major differentiator for you when you're trying to hire people. But I don't think that that's something that's particularly new or novel or magical, because the idea of putting people at the center already goes back to understanding what continuous improvement looks like, because the people that are doing the assembly work, that are doing the machining work, that are doing the process design work, all of this stuff is critical to putting the decision-making ability and putting the facts to make decisions at the people who know it best. So capturing that in a digital way and feeding it back to the right people and feeding it up and down a chain of command or up and down layers of an organization, that's what the future of software and manufacturing looks like. And looking at tools that are actually living in that space and developing towards that space will help keep you competitive, and it'll help keep you on the cutting edge of what actually exists in a manufacturing technology space. The idea here is to make sure that these changes are not just coming out as one-offs. And what we've seen over the last half decade or decade is that software projects tend to boomerang. And that means, it's somebody who's attempted a machine monitoring project, or they've attempted to do a scheduler installation, or there's all these individual silos of software-based productivity that get rolled out, and then they die or they flatline, and it's basically due to lack of integration. And that's not because the software was bad, and it's not because the shops that have attempted them were bad, and it's not because IT blocked it. None of these are the actual root cause. The root cause is the level of maturity of the industry, and that being at a place where the software was just not ready to actually stick in the way that it has to. And so meeting in the middle between what's the approach to speccing out and buying and maintaining software versus the software itself and what it's able to offer, and the extent to which vendors are making unrealistic promises about automation versus focusing on immediate value and incremental improvement. That's where we're going to meet in the middle, and that's where the entire industry is going to move forward towards this augmented future in manufacturing. That's all I've got for today. Jacob, you have anything else, or should we take it to questions?
I think we can take it to questions. We already have some questions coming in. answered one from Colleen, but to answer your second question, Colleen, we do have the ability to use LED lights. Light projection isn't something that Tulip is offering, but definitely LED lights kind of indicate visually to operators what their next step is, or error-proof a process with visual feedback. So that's definitely something that we offer, and check out our website to see more about that.
Another question that we just got is, how does Tulip differ from an IoT platform?
Yeah, so Tulip is more than just an IoT platform. We're a no-code platform for apps and operations. So we have IoT capabilities, but more than that, we can integrate with systems. We have that element of digital work instructions and being able to build interfaces to guide operators. So IoT is just one segment of what the entire platform offers.
Another question, can you revisit / clarify one of the earlier slides with the 41% and 18% statistics on current digital implementation?
Sure, let me bring that one back up. So the stats on the bottom right specify that only 41% of companies even have an enterprise-wide digital strategy, and only 18% of companies rate their use of digital technology as very effective. So the source of this is from a Forbes poll. This isn't a Tulip statistic. I don't have a whole lot of additional visibility into what those statistics are, or what the methodology was, other than to state very clearly that this is exactly what we have found as well as we go to market. Is the companies that are successful that are most successful have something of an enterprise-wide digital strategy. And part of the headache when we're trying to bring companies forward and get them interested in Tulip and interested in digital transformation more generally is where there's not a digital strategy, we end up doing a lot of customer education on what digital strategy needs to look like. There's also kind of a second category that I think tends to be overlooked, which is there is a digital strategy. It's just not necessarily well documented or articulated. So that's a case where the strategy exists, and the strategy may be, we need to be more digital, or we need to buy software for management level software, or we need better visibility. And having that agreed upon by various stakeholders in kind of the buying process, that is more of a strategy than you might give it credit for. I think one of the reasons for the low numbers here, based on kind of our experience, is companies not necessarily realizing that they have more of a digital strategy than they think they do. On the other stat, the 18% of companies rating their use of digital technology is very effective. There's two sides to it. It's what's the extent to which you have or are using digital technology, and then it's what's the extent to which that's actually working for you.
Another question, in your examples, what technical skills, coding, electrical engineering, UI, UX design, etc., were needed to implement Tulip? What skills does Tulip provide to implement?
Yeah. Russ, do you want to take this one?
Yeah, I love this question. So the idea behind the Tulip platform is that we're no code. So that means that you need to have the ability to, interact with computer software like you would a PowerPoint slide. So you can basically drag and drop elements onto a screen and understand that, you're tying fields to a data source of some sort, but it's not an extensive, you don't need to be a developer to use the tool. And if you have engineering skills, or if you have UI UX skills, these are things that you can bring and kind of tweak your Tulip app building experience based on what you're good at. So if you're really, really, really good at data mining or at data connectivity, then your apps are going to look more, data centric in that way. If you're really, really, really good at clean design, or if you love doing mobile design, then your apps might look more like, more towards what am I going to do on my phone with the interactions. So the idea behind Tulip and any no code platform is that you're democratizing this idea of using software for you. So it's putting another layer of abstraction over top of code and letting you build stuff with user friendly, normal person friendly tools, rather than having to call a coder and have them build what you want.
As simple as this PowerPoint slide that we put together. And if you can understand basic if this then that logic, you can understand how to make a Tulip app work for you. And we offer a ton of resources, from our community of users around the world who are happy to jump in and answer questions. We university courses and a library of apps and connectors and templates that people can get started with.
Yeah, we look at the resources as basically 3 tiers. So as you onboard with Tulip, there's university coursework, which is e-learning. It's formal in nature. There's testing and certification at the end of that coursework. That's all included for any Tulip user. That's the most formal method. The second most formal method is through the knowledge base. So this is a self-serve platform where you're digging in and finding essentially, wiki articles on best practices or common techniques, those sort of things. And then the third layer, which is the least official but also the most expansive, is basically the community. So this is a forum-based peer-to-peer option. So basically posting a question to the forum and looking for best practices there. The next question was, do we have any built-in APIs for ERP? Jacob, you want to talk about connectivity?
Yeah, so our APIs are configured through a low-code interface. Basically, if it has a public-facing API or one that someone can easily access, we can connect to it. We have customers that connect to their ERPs all over the world, various different types of ERPs. And then we do have some pre-built connectors to common ERPs and systems in our library, tulip.co/library. It's worth checking out and exploring some of the ones we have there. But short answer, yes, we can connect to most ERPs. Yeah.
Another question is, does Tulip offer a ready-made solution if I don't want to build my own app?
Yeah, so jumping off of that library train, so we have a library with over 250 pieces of content in it. These range from examples and templates to full-blown app solutions that you can get started with just a little bit of configuration. So if you are interested in that, someone can happily talk you through and walk you through that journey of some of the ready-made apps that we have available.
All right, I think we're going to have to call it. There's still questions to ask, but that's all the time we have for. I hope everyone found this webinar valuable. Thanks to everyone for attending. Thank you, Russ and Jacob, for the information. This presentation was very interesting. Thank you for fielding these questions about the material. Thank you all for joining us, and enjoy the rest of your day.